Hello, thank you everyone for attending this presentation about revealing where public investment is most needed. My name is Jaime, and this is my colleague Lee. We are both part of the geospatial team at Jacobs. Today, we will be sharing with you how we have been working with Transport Scotland in order to evaluate the public transport infrastructure using a GIS-based tool to help government in making crucial investment decisions for the future. We really hope that you enjoy this session and feel inspired by our approach to solve the challenges that we will be sharing. So this is our roadmap for today's session, that we will start with a quick introduction about the project within which we have deployed this tool. Then we will share some of the main challenges that we face and our approach to solve them. And after that, we will showcase how we represent our outputs using web maps and operational dashboards. Finally, we will talk about the great benefits that this piece of work has provided. So this tool that we are sharing with you today, and which we call National Public Transport Accessibility Tool, is part of the Strategic Transport Project Review, which is a program dedicated to assess the performance of all the strategic Scottish network, including bus, tram, ferry, rail, and the trunk road network. The main pillar of this project is to improve the connectivity and the accessibility at the same time that also aims to improve the sustainability and contribute to the economic growth of Scotland. NAPTAT, which is the acronym that we use for this tool, was developed within the appraisal stage for this project, assisting in the decision-making by reporting metrics and useful insights, not only about the current public transport status, but also to identify the potential benefits that some of the proposed interventions evaluated at this stage could bring into the future. So, what is really important about this tool is that we had to provide the data and insights that will help with critical transport infrastructure decisions for Scotland in the next 20 years. So, why NAPTAT? Why was so important to develop this GIS-based tool during this project? So we could say that the need of developing this tool was a combination of various factors, starting with the lack of existing public transport models to reflect the travel patterns. So NAPTAT was able to fill in this gap by providing very useful information. In addition to this, it was also very important that in the appraisal stage of this project, public transport behavior could be quantified and reported at different geography levels, which was one of the goals that we achieved by implementing this tool. Ultimately, developing this tool brought also the opportunity to create a national accessibility model, which can be used for different purposes in the future. So maintaining this tool updated will also help in the decision-making for other different purposes in the future. To develop this tool, we consider all the possible ways of public transport in Scotland to evaluate its current performance in terms of accessibility, frequency, and journey times. For doing so, we generate a 200-meter grid covering the whole country, which results in more than 2 million points to evaluate. Its grid square-centered was considered as an origin point for any potential travel, so we calculate its accessibility to the nearest public transport locations, the frequency of the services at these locations, and the journey times from these locations to different types of key destinations that we split in different categories, such as employment, healthcare, education, retail, or food stores. For doing this, we consider different parameters in terms of threshold distance to reach the transport public locations from each of the origin points, depending on the mode of travel. And we also consider walking and cycling as two different ways to reach a public transport location from any of the origin points. So, as you can see, the main challenge here was to translate a huge amount of data so we could extract meaningful conclusions, which I'm sure is a situation that many of you here today can relate to. In order to digest these millions of records and their spatial interactions, we use different automated solutions that help us in obtaining the final results. Network Analysis Extension for ArcGIS Pro was one of the most important tools that we use, as it helped in the identification of the public transport locations in the vicinity of each of the grid centroids, as well as identify the destinations that can be directly accessed by walking or cycling from any of the origin points. Then, using the network analysis outputs, a Python script was used to calculate specific scores for each of the origin points based on the number of locations nearby, the distance to them, and the frequency of the services at these locations. At the same time, the same outputs from the network analysts were processed to serve as input for TRACK, which is the GIS-based transport modeling software that we use to calculate the journey times from each of the public transport locations to all the destinations. With all the results from these previous processes, we then generate different raster datasets containing the final results, representing the accessibility score, the frequency score, the overall score, as well as the journey time score for each type of the destinations. Finally, we overlay these outputs with the population centroids that represent all the populated areas within Scotland. So what this means is that we were able to report all the results at different geography levels. So, after completing all the previous analysis, we did know for each population zone how accessible the public transport services are for the people living in that area, which is the frequency of these services, and how long the journeys are for these people when they want to use the public transport to reach any type of key destinations. However, we wanted to go one step further and enhance those results by incorporating useful demographics data with the aim to provide additional filtering and interrogating options into the final outputs that will add some extra value to the tool. To achieve this, we incorporate information about the population numbers for each area, the employment data, the mobility data, the household occupation data, and we also link the results with the Scottish Index of Multiple Deprivation, which was particularly useful as it assists in reporting metrics under the Equalities Impact Assessment. As a result, by incorporating all of this additional data, we were able to provide useful information in addition to the public transport behavior metrics that could help in the identification of hidden patterns related to the public transport efficiency. And now, Lee will take you through the very fancy outputs that we generate and all the benefits that this tool has provided to our client. So please enjoy Lee's demonstration.
Thanks, Jaime. Now, hopefully, after seeing all of the data sets that we had to manage, all of the different methods of processing and analyzing everything, you guys are excited to finally see some nice, easy-to-digest outputs. So our final outputs are visual and fully interactive, so that the data, the information, and the conclusions can all be interrogated, filtered, and used by anyone. You really don't need to know how to use GIS to analyze these results or to make any sort of calculations. So on screen now, you can see our first output, which is a classic web map application with the layer list on the left, the map frame in the middle, and the legend to the right. Within the layer list, you can see we have layers for the baseline results, which are the current conditions, layers for scenario package results, which are the results of a model simulated by the transport planning team with suggested improvements to the public transport network, and finally, some comparison layers to show if there are any benefits of the scenario model to the baseline results. Within each group, you can view the overall NAPTAT score, the journey time scores, and the individual journey time itself. We also have a few layers for employment accessibility results, and for realistic results, we have split employment by urban and rural classification. This just means that you can view the journey time for all of the rural regions and separately for all of the urban regions. Plus, we also have an additional layer for the total number of jobs within an urban environment. So within the map, the user can also interrogate the data. They can select geographic boundaries to understand what the region is that they are looking at, and within the attribute table, they can view the associated score for this region too. So next, onto our dashboard outputs, where the user can really start to interrogate and customize the data for their own study. Since we had so many different parameters and calculations to include, we decided to avoid creating one massive complex data results dashboard, and instead create separate dashboards, each with a different aim. So first up, we have the overall baseline dashboard, which can be used to view the current performance of public transport in Scotland. And you can view this on screen now. So at the top of the dashboard, you can see that we have split the data into different journey destinations, such as high schools and hospitals. As previously mentioned, we have also further split employment by rural or urban classifications, which is why this column looks slightly different to the other destination columns. On the top taskbar, you can filter by geographic boundaries, and on the left taskbar, you can filter by journey time to each destination type, from 0 to 120 minutes. The main body of the dashboard is built with indicator cards, where the first row shows the percentage of population accessibility of each destination, and the second row shows the average journey time for these two. On the right, we also have the overview map, the link to view the web map application that I showed previously, and the overall NAPTAT accessibility score. Next up, we have the comparison dashboard. So this dashboard will now allow the user to do a direct comparison between the baseline conditions and the scenario results. The user will now be able to quantify exactly how many more people now have access to each destination type and determine the new average journey time in comparison to the baseline results. So let's have a look at some specific improvements. So I've just applied a filter to the dashboard to the Edinburgh and South East region. And looking at the overall NAPTAT score to the right, we can see that this has increased by 1.6 for the full region, which, for a bit of background, has a population of over 1 million. Looking closer, we can try and see if we can pinpoint where these improvements are occurring exactly. If we focus on the hospital destination column, we can highlight that over 25,000 people can now access a hospital in under 30 minutes, which would be a major improvement to the public transport network. Using the filters again, we can even lower the study area further and pinpoint where within the region these improvements are occurring, which within this case was the city of Edinburgh. So now our transport planners can clearly relate a suggested improvement in journey time to hospitals in under 30 minutes within the city of Edinburgh when writing their reports. And finally, we have one of the additional dataset dashboards. The one on screen is the SIMD dashboard, which includes analysis against the Scottish Index of Multiple Deprivation dataset. So we now have 3 new buttons in the dashboard that will allow the user to now filter the results by the 20%, 10%, and 5% most deprived areas in Scotland, in addition to the current geographic filters and the time slider filters that we already had. So by providing socioeconomic analysis, we can now help the team to start and pinpoint which vulnerable areas may require improvement in the public transport network, but also provide some insight as to why certain areas may have already been deprived within the baseline results already. So by consolidating and processing all of these results using GIS, we were not only able to create one single detailed database of results, but we were then able to really go to town using Esri's online suite of applications to display this in the best way possible for all of the teams involved in the project without drowning them in information. Some of the benefits that we have included are users being able to easily pinpoint areas of low accessibility that may require improvements as suggested by the model, to easily isolate data to custom selections to avoid being overwhelmed with masses of information, to quickly summarize statistics and clear improvements to the public transport network as suggested by the model to support part of the appraisal metrics, and finally, we were also able to create some supportive figures from the results for the final reports to really help push the recommendations being suggested. But from a wider perspective, the main benefit of the NAPTAT tool was to help the government increase the effectiveness of Scotland's public transport infrastructure. To not only benefit its people, but of course with less demand for car journeys and a greater push for public transport, we really are trying to help the planet too, which is something really close to our hearts as geographers, making this project so much more important to us. So this tool really helped solve a massive challenge on the project. For starters, this is a national model that covers the whole of Scotland, including all of the different boundaries within, such as local authorities. And for this piece of work, we were also anticipating a lot of different requests for data analysis to support the transport team when discussing their interventions. So the addition of our tool really built in that flexibility to allow the user to dive into different elements of the tool without reaching out to the GIS team for support. They can report on general accessibility, or they can look into the statistics of a specific destination, such as a hospital, or even perhaps there may be a deprived area within your study area that you just need to ensure is included in the conversation when suggesting your intervention. The dashboard and map combination also allowed us to have a quantity of benefits to visually see and pull out narratives. If this was done solely within the transport team, they would have traditionally been using tools such as spreadsheets. And so our tool really helps bring in efficiencies and gives our client a much more innovative and flexible solution. On screen now, we also have a quote from Kyle in the transport planning team, who says, "The spatial components of the tool were imperative to assist in analysing the public transport accessibility across Scotland, of the baseline, the proposed interventions, and the comparison between scenarios, but also the use of digital platforms to understand the outcomes both quantitatively and visually." So if you are working on data-dense projects where efficiency in terms of collaboration and long-term decision-making are key, then I hope you have been able to relate to the challenges we have faced and feel inspired today to apply similar approaches to meet similar challenges in your own work. If you have any questions or wish to reach out to us, please do feel free to stay behind after the session today, or if you prefer, you can reach out to us on email, which we have on screen. But thank you for listening to us today, and I hope you enjoy the rest of the conference. Thank you.